Yeah, no, you're good. We can use the recording.
Okay. All right. So when they're all as one unit, it would be a lot harder to actually have a keyframe animation for all of that then suddenly transitions into all of those individual animations. But using procedural animation, this is not only achievable, but I think it would actually be very easy to do and fast. And it looks good. So that is one reason why procedural generation is really powerful. And it's easy enough that we are even going to kind of simulate that animation in today's workshop. All right, so that, oh, and those are some resources. I'll share these slides after the workshop. Okay, so let's go into the project. And I'm in the folder with the 1 in front of it, and I'm in the IK test scene. All right, hopefully everybody is up to this point. If you're not, I'm just going to be explaining something, so try to catch up.
Wait, I don't know if this is just me, but I don't think I have the IK test scene.
Yeah, it's not showing up for me either.
It's not here.
Did I really forget that? Okay. I can just hot fix this. Wait, is there one scene inside of that folder though?
There's the PA implemented scene in the second ProcGen folder.
Okay. Yeah, I'll just export a new package. Yeah, my bad, guys. I'll put it in the Unity classroom, and you can download it from there. Unity classroom. Okay. And when somebody downloads that, can you tell me if that worked or not? Does anybody need help finding where that package is?
All right, it works, at least for me.
Okay.
I think.
And the scene looks like this?
Yeah, I see this little shrimp and these
Wait,
floating
is it in the GitHub?
It is in the Discord, in the Unity Classroom channel.
Oh yeah, I see it.
Okay. All right. Is anybody still looking for it, downloading it, importing it? Just so I know if I need to wait a little.
I'm still getting it working.
Okay. I'm going to talk about Bug Snacks then. It's so fun. It's a really good game.
I love that game.
Yeah, it's almost like Pokemon.
It was so good.
I really wish I could. I really wish you could fight Bug Snacks together.
They'll release like an arena mode DLC for Bugsnax.
I mean, it really is just kind of Pokemon.
It would work.
Yeah.
It would easily work.
Because like they attack you, right? But it'd be interesting to see them interact with each other more.
It would.
Mm-hmm. And they got the type advantages. Oof.
That'd be hilarious.
What do you think? What's sour strong against?
Sour. I'd say sweet, but that wouldn't really make sense.
I don't get the like the flavor wheel, you know?
Yeah, I don't either.
Because like it doesn't feel like the opposites for any of them.
Yeah, everything's more well, not everything's complimentary, but it's definitely not like
Bro, you don't want a bitter sour muffin.
a bitter side. Not everything's complimentary.
Yeah, okay.
Bitter just gets half like times two. Well, everything has times two resistance to bitter.
Bitter's normal type.
Bitter's normal type, yeah. Exactly.
Okay, I'm gonna assume that was enough time. Alright, so even if you're still importing and downloading and importing, I'm pretty much just gonna show you our implementation of, well, our use of inverse kinematics in this project. So you can see that this is a 3D model. It has bones in it, and it's just a really simple model with like two cubes. What we're gonna do is we're gonna expand armature completely so that you can see this bone 001 end. And what we're gonna do is we are going to add a fast IK fabric to it. Okay. And once you have that, you should see these green boxes. And what this does is, let me reword that. The three variables that we care about here are these top three. We're not going to worry about these down here. What chain length does is it tells the script how many parents up it should go for the arm. And since we have two bones here, and this is just an end, it's not actually a bone. So we have two bones here, so we say chain length 2. But if you had a longer arm, you would want to increase that. And this is important because remember, we're only working with a chain of bones because we want to work with an arm. If this was like, if you had like branching paths with other bones in like a tree pattern, I think this would break. I'm not certain though. Okay, so the next variable that we have here is called target, and it wants to transform. You might notice that in the scene we already have a game object named target, so let's drag that in. And you should also be able to click that circle and it'll bring up this menu and you can search for target in here. Alright, so now that we've set the target, let's try playing and see what happens. So pretty much every time I go into play mode, I'm going to immediately switch back to scene because it's easier to work with and see what's happening. So I want to move around the target, and you can see with inverse kinematics, wow, it's doing the thing. Cool. You can see that once it's outside of range, it'll just kind of stick out and point towards it. But if it's within reach distance, it will naturally bend to the target. And this is exactly what we want. You can also see that there's some weird deforming, and that's just that's just a consequence of how bones work. It kind of distorts the mesh. And sometimes it looks really bad like that. With like all that rotation and stuff, we don't really want that. But there are two things we're gonna do to kind of minimize that. the one thing is that we're going to be aware of where we're moving our target. We don't want it to be like going all over the place. But that just has to do with like, you know, what we do in code. And the next thing that we're going to do is we're actually going to go back to where we added the fast IK fabric. And in the poll area, we're going to drag in the poll game object in the scene. It's the blue ball. So once you've dragged that into that poll parameter, you can kind of see that if I move this pole around, the leg is going to bend towards it. And that's what this does. The pole determines which direction the leg will bend in. So if I move this pole a little bit more up, so now, no matter where I move this target, that knee is always going to be facing upwards. And for something like a leg, this is really useful because legs don't bend like, you know, legs don't bend like this. I mean, if yours does, see a doctor. But these two game objects, just the pole and the target, are enough for us to fully control this leg with inverse kinematics. Okay, so that's what I wanted to show for inverse kinematics. Let's actually start implementing some stuff. So we just have a leg, but we probably also want a body. So let's create, oh, not that. Let's create a 3D object and make a cube. It's so small. Make sure that's zeroed out. So it's right next to the leg. And I'm just gonna make it a little longer, a little flatter, just so it looks better. Yeah, something like that. Once you have that cube, I just closed my outline. Whoops. Once you have your cube, make sure that you drag your leg so that it's parented onto the cube. And what this will do is that it means if I move this cube, the leg will move with it. And that's kind of what we want. We want our legs to be attached to our bodies, usually. So we have that. I'm also going to attach the pole onto the cube too. Because we don't want our pole to be like all the way somewhere in the back if our body's somewhere else. Okay, so let's test how this looks. All right, so our leg is on the target. And now something we can do is we can move our body. And as you can see, since our target is constant, our leg will still go towards it with inverse kinematics, but now when we move our body, it's going to respond, and that animation is going to change. So this one is almost like it's jumping onto this sphere and like pushing off of it, right? Okay. So, yeah. So this is sort of the start of what we want to do. What we're going to be doing is recreating that sandipede. That's what the sandwich centipede is called. We're going to be recreating it. And this is kind of the first step towards that. What we're going to be doing first is making one of those little guys, and then we're going to be making a chain of them. Okay. Yeah, so let me stop and get some and take questions. Does everybody have something like this? And if you're good, tell me in chat. I want to see that too. All right. anybody has questions, yell at me. Be like, hey, stop. Okay. But I'm just going to assume that we're good up to this point. Okay, so we have this body with this leg, and that leg always points at that one target. This is the motion that we want. But this isn't useful if our body's like completely far away, because then our legs are straight. What we want to do is make it so that our leg, our target, moves with our body. But we don't just want it to move exactly with the body, right? Because then our leg would just never change its shape. I can actually show that off. It would just be completely still because the target moves exactly as much as the body. So what's our solution? Well, I actually have a video. I actually have a video about this specific thing. And I saw this video, and it's part of the reason why I wanted to do Bugsnax. It's part of that inspiration. Because I looked at what they created in this video, and it looked very similar to one of the like one section of the centipede. So you see inverse kinematics. We already do that. We do that. This is pretty much what we have already. And what they do is they attach a target point to the body. So when you move the body, it moves that target point. And then they do something called raycasting. The reason why they raycast in this video is because they want their creature to be able to walk up surfaces. We're not going to be doing that today, but I think it's still a useful way to think about how we're going to be handling leg movement. So it raycasts and keeps track of that point along the ground. And then it uses that point to calculate the distance between the leg's target, and the ground point. And if it's too far, it changes that leg's target to be where that tracked point was. Does everybody understand the idea behind that? And I am going to draw it out, just in case, if somebody doesn't understand. Okay. Well, let's actually just get into the code for a second, and then I'll check back in if anybody doesn't get it. All right, so on the body, we're going to be creating an empty. And I'm just going to call this raycaster. I'm going to give it a symbol just so that it's easier to see and seen. And if you want to add the symbol, it's just clicking on the square left of the name and picking one of these. Okay, so we gave it a symbol, and now we're going to raycast from this point to the ground. So I'm going to add a script to it called leg controller. That's right here. And let's go into the code of the script. I'm gonna give it a second, just in case anybody's code editor is opening up.
Which object is that attached to again?
It's attached to body. Oh, sorry. Do you mean the script?
Yeah.
Okay. The leg controller script should be on the raycaster object that you made. The raycaster object should be parented to the body. Okay. I'm going to start looking at the code now. So, does anybody need? If the text is too small, tell me, and I'll zoom in. Okay, so in this script, all we have is a completely empty script except for this function. And this is just to make it easier to move an object to a point. Pretty much all it does is it moves this object to this point over this amount of time. And I'll show you how to use it. Really, the important thing that we're going to do here is I'm going to be showing you how to do ray casting. It sounds scary, but it's super simple. So what I'm going to do is I'm going to define a ray cast hit, and just call it hit. And I'm also going to define a ray called a new ray transform.position negative transform.up. So its origin point is going to be our transform's position, and its direction is going to be down, straight down. Okay. Next, I'm going to do if physics dot raycast hit, or raycast ray out and hit. So what this does is it takes this ray and it checks if it intersects with anything, and then this function returns a bool, true or false. If it's false, that means it didn't hit anything, and in that case, we don't really care what happens, so we just don't do anything past this if statement. But if it does hit something, that means there was an intersect. And what this function does is it stores information about that intersect into this object that raycast hit. And something that we can do is we can get the point of intersection out of that raycast hit object. So let's do that. If vector 3 dot distance, and we're gonna get the distance between the intersection point, so hit dot point, and the transform, or no, and we want the distance between the intersection point and the leg's target. So let's actually make a variable for that. Public game object leg target, and we're putting that there. Okay, so this is that distance that we were talking about from the video. And that's just the distance that the leg is from the intersection from the raycaster. Now we want to check if that distance exceeds some value. Let's call it max dist away. And let's also add that variable. Okay, also, my bad. This leg target should be a transform. Transform, and then it should be leg target dot position. So change that game object to a transform and put that here. Okay, so we have our check now. And we're able to check if it's too far away. What do we do if we do need to move that leg now? Well, we will call a start coroutine, put lerp position in it, and give it those values that we want to be changing. For the move speed, we need to define another So let's do that. Public float leg move speed. And then I'm just going to put that here. Okay, I may have gone a little fast there, so I'm going to pause for just a second so anybody who's catching up can. But I'm going to talk about this for a little bit. So this is all the code that we needed. And if you remember from the video, this is the only code we need to recreate exactly what we saw in that video. So you can kind of notice that procedural animation, code-wise, it's not heavy at all. Like a complete beginner at programming could probably do something like this. And that's just why procedural animation is really, really good. It's a really useful tool to have, no matter what field you're in. Okay, I'm going to assume everybody's good with that, unless somebody tells me. Please do. All right, and now that we've added those public variables, we should have some fields to fill in our leg controller. Yep. So we have our target. Let's put that in the leg target. Max distance away, let's set that to a 1 for now. And leg move speed, let's do 0.1. Okay. All right, let's see how this looks. Okay. So we have our body, and I'm going to start moving that body. Oh. I don't know why it's doing that. It's kind of like bouncing back. That's weird. Oh, okay. I think it's just because I was moving the body too fast. Yeah. If I move it down a little, it'll look better. No. Is it because 1 is too low of a max distance away? What if I do 1.5? Okay, that looks a little bit more natural. Okay, so you can see, that was weird. I think that stuttering is because I can't really pull it at a constant rate. And sometimes I like go backwards or something. But yeah, you can see that now it can take steps. I don't know why it's doing that. Because, oh. What it might be is that it's raycasting on its own body. So I might need to move that raycaster up forward a little bit. Maybe more. Or inwards more. Yeah. Regardless. It gets fixed when we start to implement more stuff, so it's fine. But yeah, you can see how we can take steps now. I'll go back to the code in a second. And you can kind of tell, like, if you had two of these legs, and they like alternated, this would just be like a basic enemy in a 3D game, right? And we wrote like what, 6 lines of code, all really easy lines of code, and just set up inverse kinematics. So again, this tool, it's very, very powerful. Okay, let me go back to the code. Alright. Let me try to think about why that jittery that kind of jitteriness is coming from. And just let me know when you've got the code.
Yeah, I have the script open in like VS Code, but I realize I don't have like the IntelliSense stuff to autocomplete, so it's a little longer.
Yeah, that's fine. I would highly recommend getting IntelliSense set up though, because it makes so much of a difference.
Yeah.
Also, it kind of like sometimes you discover something new. It's like you just randomly typing something in and you're like, oh hey, what's that?
Yeah.
Yeah, it's a fun time. Okay, I also seem to have figured out what was causing the jitteriness. I think all it was I needed to increase max distance away a bit and lower the body closer to the ground. So it's not like sometimes too far away from the ball even after it's tried to move there. I think that might have been what it was doing. But yeah, you can see this is kind of working now, and it's a lot more consistent. You do still see that jitteriness, but like I think that's just because I can't move the body smoothly by hand. Okay. So we've attached that leg to this body. Cool. But I don't want to add 3 more legs in front of you guys, so let's just go to the 2 folder and move into this PA implemented scene. And you can see that I've built out a little guy with 4 legs. And he should be able to play. Open this up. And what you want to move is Sandipede, not the actual entire game object. So if I move this, cool. It does that. Missing references. So what we need to do is go here, open Sandipede, open leg raycast. And for each of these, we want to set its new target. So let's do that over here, over here, over here, and over here. Does anybody have any questions on how to do that? Okay. And that should fix it. Okay, move the body. Oh, and now it goes. Now it's a guy. Look at this little guy. Look at him. Look at him go. Little buddy. Okay, so this animation doesn't look quite as good in reverse. And that's just because we only we only programmed it really to work going ahead. And there is one glitch where there's a glitch where if you kind of like move them around too fast, it desyncs the animations, and then they all move at once. And that's not really what we want. That's not realistic. And there is a way to program it so that that will never happen. But we're not going to worry about it. If you're interested in expanding out this code base a little more after the workshop, you can try to figure out how to fix that. But for now, we're just going to accept that that's a thing that happens and not worry about it. Okay, so we have a guy and his legs work, right? But I don't want to keep on dragging him around. That's annoying. So let's go to this script, the Centipede controller. And let's make a move. So I'm going to add a public float move speed. And in update, I'm going to add this line, transform dot position plus equals transform dot forward times time dot delta time, and then times move speed. Okay. And that should just make our guy move forward. One other thing, I'm going to set this default to 3. Okay. So I think this script should already be on the Centipede body. Oh, is it not? It is. Okay, so this controller is already on him, and we'll play. Oh, look at him go. The animation's messed up. Oh, it shouldn't mess up from the beginning. That was weird. Yeah, okay. So now they're a little bit desynced. I don't know why that was weird. Okay. Yeah, so we have kind of just like an independent guy. He's moving on his own. His legs work. What a guy. Good for him. And something we can do now, now that our hand's free, we can actually change his rotation. And you can see that now that I'm changing his rotation, his animations still work. And this is part of the context, what did I call it? Context dependent nature of procedural animation. Because usually this would be kind of hard to do with keyframing. And like you can see how the legs kind of stretch out when it's on the back leg. That's like a part of like real physicality that's really nice to look at, and really gives this little creature life. And we didn't really even do anything. We set up inverse kinematics, we set up a script to control the leg, and then we made him go forward. And we already get this really cool, complex behavior. Something else I can do is rotate him up. There he goes. You can kind of see how raycasting works. It raycasts from that object down to the ground. I can also make him go into the ground. But you can see, even after I put him in the air and then put him back down, his animations will kind of catch him as he gets back down on the ground and more comfortable. Okay, yeah, so that is what we've done to implement one of the guys that we want. Now let's implement, I'll take questions now. And after we take questions, we'll move on to making that longer chain of guys. Here's the code again, in case anybody needs it. And are there any questions about procedural animation inverse kinematics?
I just got a comment real quick. It is way too fun to just pilot around the little guy.
Yeah. Because it just feels so real, right? It's like, it's like, uh, you can really feel like that thing is alive. I gotta go there.
Yeah, totally.
Okay, so if there aren't any questions, we will move on. First thing that we're gonna do is we want to add a public transform called target. And this is different from the target that we're gonna be using for our inverse kinematics. This is going to tell us, am I trying to follow another centipede? Okay. So if I have a target, I also want a minimum. Wait, no. Okay, so I have a target. But a centipede should also be able to function without a target, right? Because there needs to be one at front. Normally you would do some like inheritance stuff with classes here, but we're not going to worry about that. We're just going to do it in one script. Okay, so let's say. For this, we're gonna say if we're gonna define a bool, and we'll call it front centipede, and we're gonna set it to false. Then we're going to do an if statement, and we're gonna check if our target is equal to null. If our target is null, that means we are not following anybody. So our front centipede is true. Okay, and the reason why we do that is if you are the front centipede, then no. If you are not the front centipede, then look at if you're not the front centipede, look at your target. And that makes sense, right? Because if you're behind it, if the front one rotates, then your back one also wants to rotate to match it. Man, my Unity is slow today. Alright, so what we're gonna do is we're gonna drag this prefab, add another centipede into the scene. And I'm just gonna move it back a little. This should have a centipede controller on it already. So we'll go down to this centipede object here, and we're gonna drag the centipede into that transform. And make sure you're doing the right one. It's not the wrapper class above it. It's centipede. Oh, sorry. Okay, and once you've done that, let's test it out. Oh. Oh, okay. I forgot to change the targets of the prefab. So, you know what? Let's not use the prefab. Let's just take this, select this object, copy and paste it. That's fine too. And we will, again, do the same thing, drag the transform in there. And move it back. Okay, let's try it now. Okay, cool. Animation's broken again. But they are in a line, and if I move this one, He follows. Nice. Now they're a little train, little bug train. But you can notice that the more I rotate it, the closer the other guy gets, right? And I don't want that. I want them to stay a certain amount of distance away from each other at all times. So let's add that in. Public float. Public float min follow distance. And I'm going to set that to default to 3. Okay. So we know that if we don't have, if we have a target, then we want to stop if you're less than min follow distance away. So what we're gonna do is, what did I say? Sorry, I'm just looking at something code right now. I think I'm gonna refactor this code. So get rid of this. And now I'm gonna do if front is centipede, or, and then this is the distance check. So vector3.distance. We'll take the target position and your own position, and we're gonna check if that is greater than min follow distance. And if it is, we will move forward. And we will also move our transform look at to the top here. All right. And the reason why we set it up like this is if you're the front centipede, no matter what, you're going to walk forward. And that's why this is an or here. It doesn't matter if the distance is greater than front centipede always goes. There's another reason why we use an or here. Since an or means that the left expression is checked first, it won't check this one if this is true. And that's important because if this is true, our target is null, and this would give us a null pointer error. Just some style stuff. If you're not interested in programming, this won't really be relevant to you. But yeah, hopefully everybody has something like this. And let's see how that works in Unity. That's good. Yeah. Okay. Okay. And we see they're going, and when I rotate this front one into the other one, you can see he kind of like waits. He still looks at the other guy, but he doesn't go forward. And you can see that behavior is like kind of cute, right? He's like, "Oh, where you going? Where you going? I'm waiting, waiting his turn." So polite. And we can actually expand this with more sections. So I'm gonna make another one here. I'm gonna make another one here and drag this centipede into this one. They're the same name, but you still need to drag it in to update which one it's following. And then duplicate this one, and then drag this new one in here. And the reason why I'm not spacing them out is because we already programmed in minimum distance follow, so it shouldn't matter how far we keep them apart to begin with. They'll spread out eventually. Alright, so let's rotate this. That was the wrong one. Let's rotate this first one. And everybody else waits. And then they change direction based on everybody in front. Wow. Amazing. Absolutely incredible. Alright, so let's make them a little faster. Let them go. Wow. Sorry, I'm kind of getting distracted. like Alex said, I really like just watching them. Oh, I put the speed too high. Whoops. There he goes. Off into the distance. Okay, so we have behavior for following. And we saw the more sections that you add on, the more complex this animation becomes, because all the other ones like rotate as the ones in front start to rotate a little bit too. It just looks very interesting, and that's what we want. And keep in mind, tiny script that we implemented here, and we get that animation. I could go over a polish thing where their bodies will kind of like bounce from side to side. Do you guys want to see that?
Yes.
Okay.
Yes.
Yes. Yes. All right. I'm going to add a couple variables here. A public transform body, a public float wobble intensity, and I'm going to default this to 4. And then we'll also make a public float wobble speed. And I'm going to default this to 30. Okay. So the basic idea behind what we're going to do for the wobble is I want the body to wobble from side to side. And something we can do is we can change its Z rotation to rotate it like that. But I want it to be completely self-sufficient and just like do that based on time. So I'm going to use a sine wave, if you remember, kind of like that wave-like motion, to create that wobble effect. So I'm going to do vector 3 body angle, and this will be the body's rotation. Next, we're going to alter that body angles Z component by making a sine wave. What we're doing is we're using time.time, and this just describes the elapsed time since the start of play. So when plugged into sine, it just gives you a continuous wave. We'll multiply it by wobble intensity. Wobble speed. So the higher your speed, the faster intervals that sine wave will be. and then I'm going to multiply that by wobble intensity, and that will be the amplitude of our sine wave. And finally, we'll set those angles back to the main body, like that. Are there any questions about that? Oh, I should stay on the code for a second longer. Yeah. So you could also do this with Unity's animator. I just really wanted to make a point to not use the animator at all. But yeah, this might be easier. Might not be easier to do with the Unity animator. Yep. Okay, and I'm gonna show it off now. Target. Body visual. Okay, yeah. So all of these should be good to go. Let's try it out. I think the wobble kind of adds a lot, because the unfortunate part about this this recreation is that I wasn't able to get it to walk as fast as the Centipede in the game, but the wobble really kind of compensates for that. So yeah, let them go. And since we put that wobble code in that if statement, if they're still, they won't wobble, and I think that's another layer of that animation on top of it for that realism. Camera control is obviously a little difficult, but yeah, I think that is I think that is pretty much all I want to show you guys. Yeah. So again, if you have questions or if you're not to this point, let me know. We have plenty of time to figure it out. And if you're interested in expanding on this project, the things to focus on are fixing that simultaneously leg glitch. You even see it there. Less so, but you can still see it. You would want your legs to be spaced out very, very exactly, pretty much, so that it never happens when it goes too fast and it messes up the animations. The other thing that you could do is make it go up uneven geometry. And the video that we watched earlier will kind of explains how to do that. So if you're curious, you can look at that, and it'll kind of point you in the right direction. But other than that, yeah, that is all the content I prepared for today. I hope you guys enjoyed. I hope you learned something. Slides and the project will be put in Unity Classrooms afterwards. So if you didn't catch that, if you wanted to look at something, you can look at it there. And if you didn't catch something, this is recorded and it's going to be put up on our Twitch channel, YouTube channel, so you can go back and watch it. All right, thank you for coming. Thanks, Diego. I appreciate that. I was really excited about this workshop because I've never done procedural animation before, and this was a fun learning experience to figure it out. And I did follow tutorials, but I don't think I didn't look for anything, but I don't think anybody's recreated this specific animation before. So if you can like show it off, be like, hey, I followed this workshop. I can do this now. Yeah. All right, but I guess the rest of the time we're just gonna leave it for just chill time, hanging out, and just like playing around with this stuff more, because it is very fun to look at. Alright, I'm gonna end the stream then.